My name is Maroof Shittu. I'm a student and I also self-identify as an enthusiastic amateur. So, an enthusiastic amateur is somewhere in between amateur and intermediate. So, what an enthusiastic amateur doesn't have in maybe skill or expertise, we make up with in pure, concentrated enthusiasm. I'm a screen junkie, and currently I'm an intern at this really cool agriculture and technology startup called Thrive Agric. Briefly, what we do at Thrive Agric is we work with farmers. We give them premium inputs and best practices, and also data-driven advisory to increase their yield, and then we provide them with access to premium markets. And also, we provide crowdfunding to the public so people can fund farms with us, and come harvest time, we share in the profit. So this topic, and in a few minutes, we'll be talking about how we can write apps in Python and release them on iOS, Android, Windows, macOS, Linux, and tvOS, and the web, using rich native user interfaces. I would define a native Python application as an application that uses native system libraries and native system capabilities to build applications, and this means it will be delivering a much better user experience. So, a fun introduction. Well, as in, I would have a lot of fun talking about it. Fingers crossed. So the purpose of this talk is to look at how we can leverage the fact that Python is a powerful cross-platform programming language and use it to build native apps for these fancy new platforms and devices we have all over the place, as well as the existing ones we know and love. And also, I'll be talking about the tools that the Beeware project has been working on to make such native app development accessible to beginners, such as myself, and veterans alike. And finally, we'll talk about how you can get in on the action and how you can be a part of the buzz. So, Python is a very popular language. It has a strong foothold in many areas like the web, enterprise, and scientific and computational applications, and so much more. It's used by different people at different skill levels. It's used by different people at different skill levels on a wide range of devices and platforms. But then computing is changing. 10 years ago, being cross-platform meant being available on Windows, macOS, and Linux systems. But this definition has really changed. We now have a multitude of new platforms that are available to us. Nowadays, we want to make apps for our watches, our TVs, as well as our phones and tablets. This poses a challenge to us as a Python community, and that challenge is that these are platforms and devices where you cannot use Python out of the box. Let's take the mobile space, for example. The mobile space is dominated mainly by two platforms, Android and iOS. Traditionally, if you wanted a native iOS app, then you'd have to learn Objective-C or Swift and the respective APIs in order to do this. And also, if you wanted an Android version of the same app, then it's back to school. You'd have to learn Java and a whole new set of APIs and tools. But the question is, so why Python? And like Emmanuel and Yemisi said yesterday, why not? Just a little story. As we all know, Python is a particularly simple and elegant coding language, and it's one of the most beginner-friendly languages. So like, show of hands, how many of us here started programming with Python? Yeah, quite a few. So it's the programming language that I learned how to program with. It was very exciting to learn to code, and it still is, of course. Back then, I couldn't wait to start building all sorts of apps that would change the world, solve big problems, and of course, make me super rich. So, after practicing basic Python programming for some months, I thought to myself, wow, now I can write simple Python applications. Time to make an Android app. So this is actually a real search page, by the way. Are there any Android developers here? Okay, so full disclosure, I'm in no way, shape, or form an Android developer. So if I say anything that is technically incorrect about this ecosystem, please just. Huh? I said that I am in no way, shape, or form an Android developer. I'm more like a fan. I like the Android ecosystem. So if I say anything technically incorrect, please do correct me later. And the same goes for iOS, because we'll be talking about those too. While there are many ways to make cross-platform and native apps with JavaScript and React Native and NativeScript, and even with C# and Xamarin and the likes, Python has not been very prominent in that space, although Python has not been completely absent in that area either. We have projects like Kiwi and PyMob that have been working in that space for some years. They've been working to make Python a development language for all major platforms, and they do it quite well. And I think Oladipo will be talking about this later today. But these native apps aren't really system native, well, at least according to my definition I gave earlier. And these days, mobile computing has become so much more important, and there aren't many options for Python programming on mobile platforms. And cross-platform mobile programming is still elusive. So the Beeware project aims to correct this. And this is why I get really excited about open source projects like the Beeware project and the work they are doing to make Python available everywhere you go. So without further delay, let's start the intro memo. So what are we talking about? We're talking about a set of applications, libraries, tools, and widgets, and bridges that help you create native cross-platform applications. They are collectively called Beeware. The people behind Beeware, the project itself was started by Russell Keith McGee, and you guys can read up about him online. He's an awesome guy. We have a huge group of contributors, and the project itself is managed by the Beeware A team, called the B team. Beeware, the IDEs of Python. You might be picturing an IDE, maybe like PyCharm, and maybe you're wondering how similar Beeware is to such an all-in-one IDE. Well, an IDE is simply a set of tools and libraries that enable us to, as developers, to develop and deploy software with on any platform that we have. So the difference with Beeware is that these tools try to adhere to the core tenet of the Unix philosophy, which is that each tool does one thing and does it well. What this does is it enables us to create a powerful tool chain of extremely focused but independent tools. The goal of the Beeware project is to provide the developer with tools to run Python on different devices, tools to package a Python project so you can run on those devices, libraries to access native widgets and capabilities of these devices, as well as tools to help develop, debug, and analyze these projects. And most importantly, it aims to do all this as an open source community. The open source development process has proven itself to be the most reliable way to develop robust and reliable software. And the fact that anyone can access the software, this means everyone has the opportunity to start with the same set of excellent tools, be they experts or enthusiastic amateurs. So Beeware is a Python-first framework. If Python isn't available on a particular platform, Beeware aims to do whatever is necessary to make Python available as a development language. And in the case of Python 2 versus Python 3, Beeware is looking to the future. So they support Python 3 exclusively, and it is native everywhere. What this means is if you're using an app built with Beeware, it should be presented to you as a package that is installed like any other app, either through the App Store or an installer. End users shouldn't know that the app has been written in Python. And if you're using a developer tool or library, then you should be able to install it into your virtual environment using pip install and nothing more really. No configurations. So how does it work? Like I said earlier, Beeware isn't a monolith. It's made up of shiny little parts, and each tool tries to adhere to the Unix philosophy of a tool, doing one thing and doing it well. So, based on the type of app you're trying to build, you can pick and choose any combination of these tools and use them, either some of the tools or all of the tools, or you can even switch in some tools with some other tools. So instead of trying to explain all the tools we have, and there's quite a few of them, I'll describe how you would use some of these tools based on the type of app you might be trying to build. So, for example, you want to write a native iOS app. Although Apple only promotes Objective-C, and Swift for iOS development, it turns out you can actually use any language that compiles with the Clang toolchain. So what's Clang? What on earth is Clang? I have no idea really. But in simple Google terms, Clang is a compiler front end. So basically compilers are divided into two. There's a front end that takes the human readable code and converts it into an in-memory format, which the back end uses to now convert to the machine code for a specific platform. So essentially, it's just a part of the chain of tools that the guys at places like Apple, among others, use to make all their funny C family languages run smoothly, both with their IDs and their devices. Which brings us to the first tool, which is the support tool called Python Apple Support, which is simply a copy of CPython. So this allows you to run Python code inside your iOS or macOS app. Okay, great. Now you can print Hello World in your Xcode project. It's not much fun if you can't use the native system libraries. So presenting Rubicon. Rubicon is a bridge library, and it gives you transparent access to all the Objective-C classes that iOS and macOS provide. And using this, you can write applications directly against the native iOS and macOS APIs. Then you can use Briefcase, which is another tool, to package your Python code as an iOS application bundle. Briefcase is a tool for converting a Python project into a standalone native project. It is a distutils extension, so it uses your distutils setup.py file, and then it takes the metadata in that file and uses it to generate a stub iOS project, in this case, using a cookie cutter template to create the project. So for those who are not familiar with cookie cutter is a tool that lets you use templates to bootstrap an entire project. So for example, the templates might be on a GitHub repo. So you would pip install cookie cutter and then run cookie cutter on that repo. And then cookie cutter will proceed to ask you some questions and use that information to fill in the template. And what you get is a startup project. So Beeware provides a cookie cutter template to bootstrap a Briefcase project. So when you run cookie cutter over this template, it will ask you a few questions and use it to fill in the template, which is used to generate all the necessary metadata in your setup file. So you don't really have to worry about writing the setup to make things run. You just run a cookie cutter template. So what you end up with is a simple project layout, which later on Briefcase will then use the metadata created in that output to create your Xcode project, in this case. And then this is also done using another cookie cutter template called the Python iOS template. So you don't really need to interact with the Python iOS template directly. It's just a template that Briefcase would use to generate the output project. Okay, and the next scenario, you want to write a native Android app. Android's preferred development language is Java, and you need a way to run Java on, you need to find a way to run Python on a JVM, which brings us to the tool called Buck. So I'm running out of time, so I'll just run through all the scenarios real quick. So Voc allows you to run Python on a JVM. It's a transpiler, so it compiles your Python code into Java bytecode. And then you use Briefcase again to generate an Android project using the Python Android template. The next step would be maybe you want a native desktop app. So in this case, we're going to be needing a widget toolkit, a cross-platform widget toolkit to build the UIs, which is Toga in this case. And yes, is yet another widget toolkit. Toga uses native system widgets and not themes. So when you see a Toga app running, it doesn't just look like a native app, it is actually a native app. And afterwards, you can use Briefcase to package your app again for all the platforms. So if you want a cross-platform mobile app, then you just need Toga and Briefcase. Then Briefcase and Toga will in turn use Voc and Rubicon and all the other tools to translate your Python code to the respective platforms you want. And if you want it on the web, there's a tool called Batavia, which is a CPython implementation in JavaScript. And this will allow your Toga app to run in the browser. And yes, so finally you have one code base to rule all the platforms. We have some other tools here that I'll run through quickly. These are tools that help you actually develop your program. So we have B4. It checks for things like code style and code complexity. Then we have Cricket. It's a graphical tool that allows you to identify failures in your tests. And we have Bugjar. It's a GUI code that shows you coverage of, we have Duvet, shows you code coverage data of your test. And we have Bugjar. It's a graphical interface for debugging. Allows you to see the bugs. And we have Gali, a GUI tool that allows you to preview your Sphinx documentation as you write it. So we were supposed to have a demo, but we don't have much time. But if you go to the Toga or Briefcase docs, there are very simple example apps that you would write. Simple setup would be you create your project folder and you start a virtual environment, install Cookie Cutter, and run it over the Cookie Cutter template. And you are ready to begin. So the final point of my talk is the fact that Beeware is a work in progress. Most part of it are at different stages of maturity, and you can help. So if you want to contribute, anyone is welcome. It's not just about code. A successful project requires documentation, design skills, feedback, and bug reports. So if you're wondering what you can do to help, we have a few projects that need help. Python and Colosseum. Colosseum is how we achieve layouts in Toga. It's actually a simplified implementation of CSS, CSS Flexbox particularly. And Toga itself still needs implementation for some widgets, for some platforms. So there are many parts of the projects that would require a lot of contribution. So if you would like to get involved, there's a first contributors guide at this link. And once you moved around the tutorials for a bit, everyone is welcome to join in. Thank you.